Okay, here's another solution to one of the other magnet example problems, or magnetism example problems. Two wires are separated by 10 centimeters. The wire on the left carries 15 amps, the wire on the right carries 11 amps. Each wire is 5 centimeters long. Are the wires attracted or repelled from each other, and by how much force? So the real question of this is, how can I use the two previous examples to help me solve this problem? So in one of the examples we had Ampere's rule, and that way we found the magnetic field strength at some distance from a wire that was carrying a current. In the second example we used part of the magnetic force finding, the force exerted on a wire that was in another external magnetic field. So when you think about it, the wire on the left generates a magnetic field that the wire on the right sits in. So the left one generates a magnetic field, the right one sits in that field, so I can figure out its force. Okay, so now we got to figure out if these two things are attracted or repelled. So attracted or repelled, what I'm going to do is I'm going to use Ampere's rule, or Ampere's law, and I'm going to look at the direction of the magnetic fields. If the directions go the same direction, they're going to be repelled. If they go opposite directions, they're going to be attracted. So I'll use Ampere's rule, and I'm telling you now the answer is going to be attracted, and here's why. So my thumb's the direction of the current, and current always goes in the direction of high energy to low energy, so it's going to be the flow of positive charges in physics class. So it's coming out of the page, coming right at me, and I can see my fingers are coiling around in a counterclockwise direction. So in between the two wires, it's going upwards, it's tangent to the circle. For the other wire, I want to do the same thing, tangent to the circle in between the two wires, that one's going down. So these two are going opposite directions. Since the fields are going opposite directions, the two wires are actually going to try to come together. So that's the first part of the question. Now, how much force? So combining our two examples from before, what we know is we know that we're going to use Bill sine theta to find out the force, and I'm going to use B equals mu naught I divided by 2 pi r to figure out the strength of the magnetic field that the wire on the right is in. So I've already drawn the loop that's going around in the B field there. So let's say the B field is equal to mu naught I divided by 2 pi r, that's the magnitude of it. Putting in my numbers, I get the B field to be 30 microteslas, or 3 times 10 to the minus 5 teslas, and it's going upwards, because again, right hand rule, showing how it's going up at that point. Now I know the magnetic field, I have everything I need to find the force. So F is equal to Bill sine theta. So F is equal to 30 microteslas, or 3 times 10 to the negative 5 teslas, 11 amps, 0.05 meters, even though it gives me centimeters, got to convert to meters, and they're 90 degrees to each other at that point, so sine of 90 degrees. And that tells me the force is going to be 1.65 times 10 to the negative 5 newtons, that's 16.5 micronewtons, to the left. And I know it's going to the left because the two wires are attracted, so it's going to be pulled towards each other.